this calendar pulled up when you were walking in. This is the new unit breakdown. I think I've got the majority of this listed already in our Canvas calendar, but I just wanted to point it out to you. So this week, obviously today's Thursday, we're going to be taking some notes today on solving and graphing systems of inequalities. And then tomorrow, we're just going to be doing practice over that. Okay, so I know it says Delta Math here. I'm not going to assign a Delta Math tonight because we are just going to practice in class tomorrow. The notes today take a little bit longer, so we're not going to have much time left at the end of class. So we'll do a practice in class tomorrow. Okay, and then we'll continue over Unit 2 all next week, and then we should end up with our next test on September 17th. That's a Tuesday. So this is a relatively short unit. It's only about a week and a half, but I just wanted to give you a heads up so you can kind of see that breakdown. So we'll be having another test, excuse me, another test on September 17th is when the tentative date is set. Okay, so we are getting into systems of equations and inequalities. So we're going to start with inequalities today. We need to review a couple of things. Okay, one, these are linear, so they're all still lines like we've been dealing with in Unit 1. Okay, so we know to graph lines, we would like them to be in slope-intercept form, where we can identify M and B. So we start with our y-intercept and count our slope. But then what's going to be different about inequalities is that there's not an equal sign, there's an inequality symbol instead. So we have to remember a few things. And if you want to jot this down in the margin over here or somewhere around the top, however you want to do it, okay, we're just going to make a couple of reminder notes about our inequalities and what it means in terms of the graph. Okay, so when we are graphing, we graph a line, what would be the difference in having a greater than or equal or less than or equal sign versus just a less than or greater than sign? What difference would that or equal line make in your graph? Who remembers?
Circle.
For a point, yes, the circle would be closed or solid. So like when we were doing domain and range, yes. But when we're talking about the entire line, not just an endpoint, because a line doesn't have an endpoint. So what about the entire line would be different, how we draw the line? They're all going to be straight because they're all linear. I remember back to Algebra 1. If there is the or equal, that means all the values on the line are included. And so we would draw that line as a solid line. So it would look like a normal solid line. However, if there is not an or equal on the inequality, the values on the line are not included. So to indicate that, we draw those as a dashed line. Now that I've said it, does that kind of come back to you? So our lines may be solid if there's the or equal, or they may be dashed if there's not. Okay, the other thing that matters is the direction of the inequality. Okay, so we have to determine, is it going to be a solid or dashed line? And then we have to determine, is the direction, is it greater than or equal? Or is it less than or equal or less than? So the direction tells us something as well. Because when we graph an inequality, do y'all remember shading above or below the line? That's what the direction of the inequality tells us. It tells us where we should be shading our graph. Because remember, if it was an equal sign, it's only equal on that line. Those values on the line are the solutions. However, if there's an inequality, it could be on the line if there's or equal, but the greater than or less than says it's anything above that line or below that line. Okay, so the greater than tells us we are going to shade above And this is going to tell us if it's less than, we're going to shade below. Above and below, I'm talking about shading. Okay, so those are the two things we have to determine based on the inequality, is where is the shading and is it a solid or dashed line? Okay, the rest of this we should not have a problem with because we're just graphing lines. Okay, so in this first one, I'm going to identify my M and my B. Okay, so remember, if we are in y equals mx plus b, we're in slope-intercept form. This is the slope. And this is the y-intercept. So that's how I'm going to go about graphing these lines. I'm going to start with the y-intercept, and then I'm going to count the slope to get additional points. Okay, so in this first one, what is my y-intercept? In number 1, what is the b value? 5. So I'm going to start with at positive 5 on my y-axis and plot a point. Okay, what is my slope in this inequality? -1. There's no number in front of the x, so it's an understood 1, but it is negative. So -1. So I count my slope. I'm going to go down 1, right 1, down 1, right 1. And I just repeat that until I've got myself enough points that I think I can draw a nice straight line. Okay, if you would like a ruler, I do have rulers in the supply drawers back here. If you would like to borrow one to help you draw straight lines, you're more than welcome. All right, so now I have to, before I draw the line connecting those dots, I need to look closely at this inequality. It's going to tell me, should I draw this line solid or dashed? And then it's going to tell me where to shade. So first of all, am I going to draw this line solid or dashed? Okay, it's going to be a solid line. So I'll go ahead and sketch it. Uh-oh. You get out of here. Okay, solid line. So I've graphed the line and I know it's solid. What else does that inequality tell me? Do you read this as greater than or less than? This is greater than. So it's opening to the y. So the y is bigger. So y is greater than or equal to -x plus 5. Well, here's the line for -x plus 5. Now I need to indicate that it can be anything greater than this. So my shading should be above. Now, when we say above and below, we are talking about the y-intercept, okay? Because it's above and below, it's saying y is greater than. So along the y-axis, we're going above the line. Sometimes the direction or slant of the line, it's hard to tell where you should be shading. Some people want to go left or right, and if the slope is negative versus positive, it throws them off. So always just go back to that y-intercept. Okay, so here's that y-intercept, and I'm going above. So I'm going to shade everything above this line. Now, I know some of you, I'm using the highlighter tool on there. I know some y'all may not have highlighters. Why did it? I don't know why it made those jagged lines, but if you don't have a highlighter, that's fine. You can just shade lightly with your pencil. So what this means is that I could pick any coordinate, any point from on that line or in this shaded region, and the shaded region continues forever because this line continues forever. So it's like up and to the right forever. Okay, but I could choose any coordinate from that shaded region and plug it in here to this inequality and it would make it true. So for instance, if I picked this random point, let's say here, I just pick a random point. You don't have to draw that point. I'm just putting it on here to show you. This is at 1, 7. So if I plugged in a 1 for X and a 7 for Y, this should be a true statement. So if I plugged in a 1 for X, this would become -1 plus 5. That's 4. And the Y is 7. Is 7 greater than or equal to 5 or 4? Yes, it's true, because this is this shaded region is our solution. Okay, any value from that shaded region is a solution. Make sense? Okay. Now, I'm going to skip 2. I'll do 2 and 4 in a second because those are different because there's only one variable. Let's go ahead and look at number 3. So in number 3, I've got a less than or equal symbol. So when I go to graph this line, is it going to be solid or dashed? It's got the or equal, so it should be solid because we can equal the values on the line. So it's going to be solid. Now this one is less than. So our shading is this time is going to be below the line. Okay, so now let's go ahead and graph the line. What is the y-intercept here? That's an mx plus b form. So 2. The positive 2, that's your b. So I'm going to start at positive 2. And then what is my slope? -2. So I'm going to count a negative slope. So I can go down to right 1, or I can go up to left 1. Okay, so you get you some points. And we already determined that this one should be a solid line as well. So I'm going to graph this as a solid line. Now my shading, we said, is going to be above. Or no, I'm sorry, we said below. So I'm going to go to that y-intercept below. It's all the y values below that y-intercept. So this is the side of the line that I'm shading. Shading all of this. Feel okay about that one? And if you wanted to check, did I do that correctly? You can always just pick a test point. So the origin 0, 0 is in our solution, isn't it? So we could just check zeros. If I plug in a 0 and a 0, -2 times 0 is 0, plus 2 is 2. Is 0 less than or equal to 2? Yes, it is. So we've shaded on the correct side. All right, I skipped 2 for now because I want to look at 2 and 4 actually at the same time. The difference in these is that they have only one variable. They're not in slope-intercept form. When you have just the y as your variable or just the x as your variable and then a constant, okay, that is going to be either your vertical or horizontal line. So it's either going to be perfectly vertical, straight up and down, or perfectly horizontal, left and right. Do y'all remember which is which? If it's the y, the variable, versus the x variable, which direction the line is? An easy way to remember it, or a good way to remember it, is that whatever variable is there that you see, that's the axis that you're going to cross. So if it's x, we're going to cross the x-axis, which means the line has to be vertical to cross the x-axis. Do y'all understand that? So this one, number 4, says that x is greater than or equal to 3. So that means that I'm going to have a line where x is 3 right here. I'm going to have a vertical line going through there. Now, should I draw this line as dashed or solid? This vertical line that's going to go where x is 3. Solid, because of that or equal, this is going to be solid. So I'll go ahead and draw that line at x is 3. Now, in this case, when there is no y variable, I can't go and look and say above and below the y-intercept. There is no y-intercept, right? So on this one, I actually have to say left or right of the line because it's a vertical line. So what do you think that greater than symbol tells us? Am I going to shade to the left or right? I'm going to shade to the right because I'm going to include all x values greater than 3. So that's to the right of 3. It's this side over here that's shaded. Now the y is less than 6. That line does not have an or equal. That inequality doesn't have the or equal. So that means that this line is going to be what? If there's no or equal on the inequality, is it going to be solid or dashed? Dashed. I'm going to have a dashed line. Now this one is going to cross the y-axis because y is the only variable. It's going to cross the y-axis at 6, which is right here. So I'm going to have a dashed line. It's a perfectly horizontal line through the y-axis at 6. Now is my shading going to be above or below? There's no purple highlighter. This one's not going to color code. Womp womp. Actually, I guess I'll just do the reddish color so it's different. Okay, it is less than, so it's going to be below. Okay, okay about those? All right, that's just the basics of graphing inequalities in general. That's a little refresher back from algebra. Okay, in algebra, you learned graphing inequalities. What we are going to look at today is systems of inequalities. A system means there is more than one equation. Typically, we'll look at systems of like 2 and 3. Okay, so we're going to start with systems with 2 equations, or in this case, inequalities. Okay, and when we have these inequalities, we graph them together on the same grid, on the same coordinate plane. Now, your shading, what you are looking for because we can have like this blue one, the solution is on the line or to the left of the line. Okay, but this green one, it's on this line or to the right. If we looked at these together, we would be looking for where that shading overlaps. So when we graph 2 on the same line, it's like we just did above. We're just going to graph them individually, but we're going to look for where the shading overlaps. Okay, so some people prefer to do the shading as we go. Thank you. Oh. And then some people think it starts to look too messy with too much shading happening, especially if you don't have multiple colors. If you only have one pen or pencil, sometimes it's hard to see where the shading overlaps if you shade everything. So some people don't like to shade till the very end. Okay. Let me give this note and then I'll try that example with y'all. Okay, sorry about that. All right, so I'm going to start with the first line. I'm going to pick 2 colors whose overlapping. I guess I'll do pink and yellow. It'll overlap to be orange. All right, so for this first one, This inequality tells me what about my line? Will it be solid or dashed? It's going to be dashed. Okay, and where will the shading be? Below. It's less than. So the shading is going to be below. Good. All right, now my slope is the -3, and my y-intercept is the 7. So I'm going to start at 7 on the y-axis, and I'm going to count a -3 slope. So that means I go down 3, right 1, or I could go up 3, left 1. So I'm going to get enough points to help me draw this line. All right, and we said that when we draw this line, it should be dashed. So I'm going to draw this as a dashed line. Again, I always recommend using a pencil in math, but especially with graphing, because it's so easy to make a mistake. Like if you accidentally draw it as a solid line, if you have a pencil, you can just go in and erase a little mark every so often and make it look dashed. Okay, but if you accidentally draw it in pen solid, you're kind of SOL. You either need to redo it or something. So always use your pencil. Once we're all finished and you think it's complete, then if you want to go over it in colored pens or something or markers, you can do that. All right, I'm going to shade now. I'm going to do my shading now as we go. And because I have 2 different colors. Okay, since if you don't have 2 different colors and you're not going to be able to see the overlap of your shading, I would not maybe shade right now. Or if you are shading with your pencil, I would make it look something, make it a light color here, something like this where it's shaded in one direction. So we're supposed to be shading below this line. So if you're using a pencil, maybe do something like this where it's just all like vertical shading, or excuse me, horizontal. And then when we do the other shading, you can do it vertical, and then you would kind of see where it overlaps because the vertical and horizontal lines would intersect and make like a plaid marking or shading. Okay, I'm going to use my highlighter, okay, but I just wanted to show you how I might do that if I were using a pencil. Okay, so shading below that y-intercept. So this is everything, all the y values below 7. So that's this side of the line. Okay, so I get my shading in. Oh, well, try that again. Are you kidding me? This pen is going to drive me nuts, y'all. OMG. Love it. Oh, it stayed. Hallelujah. Okay, so now the second line, I'm going to do this one in yellow. What does this inequality here tell us about our line? Is it going to be dashed or solid? It's going to be solid because of the or equals. Okay, so we're going to have a solid line. And is it going to be shaded above or below? Above. That's a greater than symbol. So above. Okay, now this time your slope is 4 and the y-intercept is -5. That b is, it's -5, so that's -5. So I'm going to start at -5 on my y-intercept, or on my y-axis. And then I'm going to count my slope of 4. So I'm going to go up 4 over 1. 4 over 1. Or down 4, left one. Now it's kind of hard for y'all to see my yellow dots on the pink. Let me make them, I'll put them in gray. Here's where I plotted my points. You can see that a little better. Okay, and we said that this line will be solid. I'm gonna draw a solid line through those points. And it really doesn't show up on that highlighting. Get the gray again. Here it is. And then we said the shading for this one will be above. So that y-intercept is at -5. So everything above that along the y-axis. So my shading for this line is above. So it's everything over here. So notice, okay, the overlap section is this orange section. So above in yellow, below in pink, the overlap is what I'm looking for. Okay, so the solution to both of these inequalities falls in this overlapped shaded area. So it has to be over here. So if I picked any random point to test, if I tested a point at, let's say, 1, 9. If I'm at 1, 9, is that a solution to this system? No, it's only going to be a solution to that second inequality because it's in the yellow section. If I picked a point at 2, -2, that's right here, that is not a solution to this system. It's only a solution to the pink one, the first one. To be a solution of the system, it has to be a solution to both. So it has to be in this overlapping section. So for instance, the origin 0, 0, that's a solution. Okay, so this is the solution set, this orange overlap shaded area. Y'all feel okay about that? All right, let's try number 2. Let's do another one. Now this time, I'm not going to use yellow because it was really hard for y'all to see that line drawn in yellow. So let's use blue and pink, I guess. All right, so I'm going to do pink again. So this first line, what is that inequality there? Tell me. It says y is less than 3x plus 2. So what do I know right away? It's going to be a dashed line. Very good. And where will the shading be for that one? Below. Now I'm going to go ahead and mark my slope as 3 and my y-intercept as 2. So I'm starting at 2 on the y-axis and I'm counting a slope of 3. So rise 3, run 1. Rise 3, run 1. Or go down 3, left 1. So you can go backward. Now when I go to graph this line, we said it is dashed. So I'm going to draw a dashed line through these points. Okay, and then I'm going to shade below. So look at that x-intercept. We're shading everything below. So there's the first inequality graphed. The dashed line and the shading is below. Now for this next one, we've got a greater than or equal. So what does that inequality tell me? Greater than or equal? What type of line will it be? They're going to be straight, but yeah, solid. And where's the shading going to be this time? Above, because it's greater than. Okay, this time my slope is -2 and my y-intercept is 9. So my y-intercept is up here at +9, and I'm going to count down to right 1. Over and over to get a bunch of points. Okay, now this line is solid. So I'm going to connect those dots with a solid line. And then we said that the shading for this one would be above. So above that y-intercept is up here. So it's everything above this line. So our solution to the system is this purple section that's created, the overlap of the pink and blue. Okay, because it's above the blue line, but below the pink line, it is this purple overlapping section that I would find my solutions. Now, what about on the lines? Okay, if I am on the blue line below the red line, then yes, it's a solution. But if I'm on the blue line above, that's not a solution. If I'm on the red line, I am not a solution because the red line is dashed. So the points on the red line are not included in the solution. It's just the shaded area and the solid piece of the line creating that border. You feeling okay about these? All right, if you flip over to the back, we're going to take a look. This one has 3 inequalities. Now, 2 of them are the vertical and horizontal lines we looked at on the front. We said if it's just X or just Y and a number, it's going to be a vertical or horizontal line. So those 2 are going to be relatively easy. But the first inequality is in what's called standard form, AX plus BY, and then C on the other side. Okay, so most of you probably don't remember how to graph from this. If you're graphing this by hand, we really want it in slope intercept form. So I'm actually going to do that first. So I am going to come over here to the side. This is negative 7x plus 3y is greater than 9. And I'm going to get this in slope intercept form. Okay, so first I'm going to move the 7x by addition. So I'm going to add 7x to both sides to get it to eliminate on the left. So I'm left with 3y is greater than, and I cannot combine the 7x and 9. So I'm just going to write it as 7x plus 9. Now I'm going to get rid of the 3 by dividing. What you do to one side, you do to the other, the entire other side. So both the 7x and the 9 are getting divided by 3. So that is 7/3 x. And then 9 divided by 3 is 3. So I can just put plus 3. So there's that first inequality in slope intercept form. So I can see that the slope is 7/3 and the y-intercept is at 3. So I'm going to graph this line first. So at 3 on the y-axis, and then I'm going to rise 7, run 3. Or go down 7, left 3. Now, before I connect those points to draw a line, should this line be solid or dashed? This one is going to be dashed. And again, that's coming from this inequality right here. So it's going to be dashed. And the shading is going to be where? Above this line. So I'm going to do a dashed line. Connect these points. And then my shading is going to be above. So it's all the y values above that 3. Everything above this line. Everybody feel okay with the first line? Now, when we go to add in those second two, so this one is x is greater than or equal to 0. So it's going to cross the x-axis at 0. So to cross the x-axis, remember, it's a vertical line. So we have a vertical line. So touchy. A vertical line through 0 on the x-axis. So we're crossing the x-axis at 0, which is the origin. So it's just a vertical line actually on the y-axis. Okay, so this is a vertical line. And it's solid. I knew it was solid because of the or equal. Now, where should the shading for this one be? Because it's x, it's just going to be left or right, but it's x is greater than or equal to 0. So what if we're on the x-axis going greater than 0, what direction are we going? Right. So I'm going to do my shading to the right of this line. So it's everything to the right of this line. Okay. Now, if those were the only two inequalities, we would see our overlapped solution is up here, but it's not. Okay, we've got another one. We've got to draw the third line. This one is a horizontal line because it's going through the y-axis. So this is a horizontal line. Is it solid or dashed? Solid because of the or equal. And will it be shaded above or below? Above because it's greater than, and we're dealing with y. So I'm going to draw this line. It is a horizontal line through the y-axis at 0. So it actually is just the x-axis itself. So there's the line in blue. Okay, and I'm shading everything above. All right, so we've got several different overlaps. We've got the yellow and blue overlapping to make green. We've got the blue and red overlapping to make the purple. And we had the yellow and pink overlapping to make the orange. And then we've got the individual yellow, pink, and this little tiny individual blue section. But what we're looking for is that overlap of all three, which is this triangular section up here, right in here. Y'all see it in here? That's where all the overlapping is taking place. So that is my solution to this 3 inequality system. All 3 overlap. Oh man. Okay, well actually that's fine. I'm going to shade it in just that section so you can see it a little better. So it is just this little triangular section here where all 3 of them overlapped because it's above the blue line, right of the red line, above the gray line or yellow. Don't feel okay about that? So this is what it would look like if you just did your shading at the end. You just have one little section shaded, okay, rather than having all the overlapping shading. So that's kind of a personal preference if you want to wait till the end in a shade. Okay, so I want y'all to take a minute. I want you to try this 3 equation. These are already in slope intercept, so you don't have to solve anything. It's ready to graph. Okay, at least get the lines graphed. If you're not sure on the shading, just wait till I go over it. Okay, but everybody give this a shot. Okay, I'm going to freeze the screen up there for those of you in class. I am recording this. So if you're watching this on a video, just pause the video and give this one a shot, and then you can come back to check it. You'll need to talk to each other, talk to your neighbors, ask questions, clarify. You're welcome to do that. I'm going to unfreeze it so you can at least check it, maybe take a picture of it, because the bell's going to ring here in a sec. This is what it should end up looking like, because you can see my horizontal line is dashed and I'm shading below. My blue line is dashed, I'm shading above. The green line is solid and I'm above. So it's just this little triangular section in the center where they all 3 overlap. Okay, I will post this online, or you can snap a picture of it and copy it down later in Cat Tracks. Okay, and we'll be practicing this in class tomorrow.